2006, I brought a class to this campsite for the very first time. And at that time, everything that you see out there was tamarisk, and these trees that are up here were just tiny little trees in with some chicken wire around them. They were about this tall.
Whoa.
Yeah, and so you can see how how fast things grow down here. They get greater than a 300-day season. These trees probably lost their leaves in December, and they probably leafed out again in late January or the beginning of this month.
Wow.
That's their entire winter. You know, it might be from like Christmas to Martin Luther King Day or something, and that's it. And then they're back in action. And it's good living if you're a tree, yeah. So you should recognize this map if you had a newer version of the book. This came in the first editions of the book, at least. This used to come as a map folded up in the back of the book. Did yours come with that?
Yep.
Two of you? Okay. So this is showing the entire length of the Colorado River. Of course, you could do this now by buffering based on flow in GIS. So now you're like, oh yeah, that's a simple operation. That's just basically, choose your background, add your rivers, and buffer it, add some labels. But so we came down, of course, through here. This is where we intersected the Colorado River, and a good portion of the book is talking about the other half of kind of western desert river systems in Utah and Colorado, and then through Grand Canyon. And then now we're all the way down. We're all the way down here. So we're way at the bottom. We're at this little curve right here where you see a little bit of a loop when you get up close. Hoover Dam is important. Glen Canyon Dam, of course, the Monkey Wrench Gang is famously written about eco-terrorists. Eco-terrorists, I guess at the time that wasn't a term. So monkey wrenchers trying to blow up the Glen Canyon Dam. But then Hoover Dam is the one we went over. But really, it's Hoover Dam where the straws really start sucking hard on the river, and it starts getting diverted into a lot of different, directions. So it's going to grow cotton, it's going to grow alfalfa, as you saw yesterday. It's really a pretty highly engineered landscape. This is a little flow map to kind of the siphons, the major kind of input rivers represented by the funnels, and then the spigots represent, where water is being pulled away to something else. So one of these is the Central Arizona Project. Another one of these is the California River Aqueduct that's siphoning river off to California. And you'll see a number of these, and only this one gets all the way to the Gulf of California. So the spigots, are large.
Only in the wet season, right?
What's that?
Only in the wet season?
Only, right now, it will only go to the Colorado River, and this is after your book. Based on some agreements between the U.S. and Mexico, there have been, I think multiple now, but at least one flow, is it 2013 or 14, when, I think 13, when they released enough water from all the dams to ensure that flow went all the way to the Gulf of California and the Sea of Cortez. And so that has happened, and it didn't happen at the time John Waterman was writing the book. It hadn't made it all the way. Now they have done it, but it's not every year still. And so the description you're reading is still an accurate description of what that place looks like today. But there's active restoration work that's trying to get that to happen, and there are active agreements. There's phenomenal collaboration. Despite all the talk of a border wall and all that sort of thing, there's phenomenal collaboration between land management agencies in rural places like this and folks doing the same in northern Mexico right now that is resulting in agreements to restore both sides of the river regardless of the border. So that's, yeah. Ricky.
Is it safe to assume that years of heavy snowfall are the years that it makes it all the way?
No, and so that brings me here. So you can't see the axes here, so I'll point them out to you and then come up and look at them as we're getting loaded into vans if you need to. We can put this up again later. This is 1905. This is time on the x-axis, and this is the year 2000. Here we have completion of major dams. So this is Lake Mead begins to fill. Hoover Dam is constructed. It begins to fill. Here's Lake Mead is finally full. Okay, so this is really the beginning of the major kind of siphoning of the river and kind of control of the river. This is the annual discharge of the river before Lake Mead. This is the discharge afterwards, annually. This peak right here is 1983. That's the peak that almost destroyed Glen Canyon Dam. That was this major flood event that's still talked about today by every boater on the Colorado River as the biggest flood, the biggest water that they've ever seen, right? That it moved boulders, people had to be evacuated, anybody who was rafting on the river had to climb up and scrounge to high ground as this giant muddy flow came through. Spillways at Glen Canyon Dam couldn't handle the flow because of cavitation in the spillway, started tearing apart the spillways. The dam came so close to collapsing they had to put plywood up on the top of the dam to hold the water back. Wow. They were literally going to the hardware store and tacking up plywood to the top of the dam to keep water from spilling over the top, because as soon as it spilled over, the waterfall effect of that would have just undercut and destroyed the dam and torn it right out.
That was at Glen.
That was at Glen Canyon Dam. That was all the way here, and it would have resulted in a series, that flood from that. If Glen Canyon collapsed, it would have collapsed Hoover Dam. It would have collapsed Davis Dam, Parker Dam, Imperial Dam. It would have flooded every city.
Yeah.
Well, awesome, except for people actually live in these places. And there is some environmental justice thinking to be done there. Some of the cheaper water or cheaper land, we're talking about RV parks near the Colorado River. So what happens when a giant flood comes through? People lose everything they own. So
and electrical systems, you got to think about why they affect our
water,
right. So it's a romantic vision to remove the dams, but it would be on the social side, it would be a human catastrophe. So, man, I mean, and we're not even talking about what's happening in Mexico with the same people whose livelihoods are dependent on getting water from the river and agricultural lands there where they're, growing produce that, you may be proud to eat. So,
and pollution.
And et cetera. So, it's a very complicated story, but in 1983 it almost happened. That's this discharge. Wow. Here's our peak annual discharge before that. So this discharge that almost did that, we're only talking about, actually I think it may have been recorded as 90,000, but the point is this was a frequent flooding amount prior to Lake Mead, happened regularly. So we had scouring floods where this river would go up and down. They say in the Grand Canyon you used to be able to walk across the river in June when everything was pretty dry before snowmelt had really gone off in earnest. And then it would peak its discharge after that, and especially in monsoon season. So you get these flood events that were massive, and then it would alternate with periods where there was very little water in the Colorado River and you can almost walk across it. So tremendous variability. So lower lows, higher highs, now it's flatline. Growing up in Oregon and Washington in the 70s and 80s, I never saw bald eagles. I had to go back to I'd go back to Coeur d'Alene, where I was born in Idaho, and annually we could find them in some specific regions, but we'd drive up to Lake Ponderay to see them, which was kind of isolated in the middle of winter to see them. Now they're everywhere. Why? DDT, right? But that ban worked, and those species have come back. Now we see these species in a way that we never saw before. Wolf populations have made a comeback. We're still challenged in getting human societies to accept them, but we're farther along than we were in the 80s.
Yeah. Oh, quite a few packs in Washington and some in Oregon.
Yeah. So these kind of changes can happen, and the other thing that's encouraging to me is that the restored forests you're going to see today, as artificial as they are, those restored forests come from a collaboration between conservation scientists, environmental groups, scientists at academic institutions, and the Bureau of Reclamation. The Bureau of Reclamation itself has a mandate to restore over 3 million acres of riparian forest. That's massive. And when you have an agency like that, and you have people like yourselves who get into those agencies and help move them, then the change is slow, but we know from experience it does happen. It does feed forward. And so I don't think these problems are insurmountable, they're just complex.
He and I are going to survey the size of the trees, and so we're going to measure the diameter of the tree at breast height and take the temperature. We've been doing that for.
This is the garden. This is the same one that you did a GIS map of, and you can see where they are. So it says established in 2005. These were actually planted in 2007. So we're looking at about 13 years. 13 years of growth here. Produced the forest you see. The trees that you see in front of you, though, these are not dead. They just haven't leafed out yet. So while some trees, and so you'll see all different stages of phenology here, and what you're actually seeing are genetic differentiation. So some trees are adapted here to leafing out right away, like this this big mama, as we call it, because we know it's a female tree. They are dioecious, male and female. This one leaves out really early. This is just like the ones at our campsite, probably loses its leaves in December, and then about a month later puts them back on again. Some of these may not leaf out for a month. Some of them won't leaf out until April. And so we have some that lose their leaves in October, and they leaf out in April, regardless of the weather conditions. And it's ridiculous. You know, it's going to be 70 degrees today, and virtually every day it'll be between 70 and 80 degrees until April. They're not picking up on the signal, so they just wait. So that's pretty fascinating.
Is that varied by genotype?
Yeah, exactly by genotype. It varies exactly by genotype. In fact, it's such a good variable by genotype that it predicts with about 80% accuracy how productive these trees are. So you can almost entirely predict how fast they're growing just based on the length of the growing season that they give themselves, based on their leaf timing.
Are these guys that still haven't leaked out from a really hot climate or from a colder one?
They tend to be from colder climates,
okay,
but they're not uniformly from colder climates. Yeah. And the reason for that has to do with the way these guys are pollinated. Okay. Anybody remember, or you know, the pollination mechanism for these?
Oh, we just talked about it.
It's wind. These are wind pollinated plants. Because of that, on a windy day, when you're getting breezes from all over the place, you can have pollen, and the wind, the predominant wind, not today, but the predominant wind direction is from the southwest. You can have pollen from this part of Arizona flow all the way up to the highlands of Arizona, where you have other trees that then get pollinated, right? And so one of our most productive trees here is actually from about 4,000 feet elevation in a place called Fossil Creek, Arizona, which is really far away on the other side of Phoenix in that direction. So past where we were just recently at Agua Fria. So how weird is that? And then it's the most productive here. The trees that came from here are productive, but they're not the most productive. It's kind of fascinating. So that wind pollination, when you mix, when you know the parents are from totally different locations, you know, the offspring, even if the parent is adapted to the location, the offspring may not be. You know, because half of their parentage comes from a different climate, maybe. Yeah. So it's kind of interesting. But we didn't know it would be that powerful of a predictor. We really, honestly, we expected that we would plant them and they would all respond to the climate here. They would all leaf out, you know, at an earlier time. And we didn't predict it to be as diverse as possible. I was just talking with the regional director of the refuge while you guys were cruising the refuge network in this part of Arizona while you guys were cruising the Natural History Museum. And this is Elaine Johnson. And Elaine was telling me that there is some recent research with yellow-bellied cuckoos that they know need riparian trees like cottonwoods to reproduce and to do well. But they've been finding more yellow-bellied cuckoos in young forests than old forests. And so they've gotten to this place where they're thinking, oh no, do we have to start thinking about cutting down some of the, you know, the larger forests and replanting with, so we get young ones. And an interesting application from this work that we were just talking about this morning is that some of these trees are small, they survived well, but they never grew very large. They're buried in the garden, and possibly you can create gardens that are of those genotypes. It would be better cuckoo habitat. So you've got this genotype by endangered species interaction that you wouldn't, you think, I want to restore forests, I just want big ones, right? I want big trees, bigger the better probably, right? Not always.
Dylan, has there been research in this site right here on bird nesting or any other ecological interactions?
No, other than Clarissa and I's classes. We brought, we've used this as a field ecology site numerous times, and sometimes people come up with questions, they want to look at genotype-specific bird nesting, and then it just hasn't, they haven't found results that show that, but it could be the small number of birds nests they found. It's about 40 acres of, this particular restoration block's about 40 acres, and then there are several other types of blocks.
So with the flooding, if you was dependent on the smaller trees, if there was constant flooding and destruction of the habitat along the river, that'd be a regular thing to have trees growing up.
That's right. That's what they're built to deal with. And so, that's the whole system kind of working. But once it's kind of a unexpected outcome of the kind of artificial nature of restoring forests. You're restoring big forests, but what about the small ones? So you might actually always need to have that matrix on the landscape.
Is this field or forest irrigated, or do you just use natural?
It was flood irrigated when it was established, and so fairly regularly they flood it and then let it drop. Now I think it's flood irrigated much less regularly, so they don't need to. These fields across the way are generally flood irrigated. Actually, this one is replanted on what's already, the alfalfa fields.
So can I just, bouncing off that cuckoo thing, I don't want to take up too much time, but if the idea is to have smaller trees, and they're thinking of just cutting down the big forests to replant small ones, then it seems like it would obviously be better to rather set some kind of system in motion where young trees will be continually establishing year after year. But how would they do that?
Well, good question. Let's look over here. So just like the forest here, in 2005, we've got pictures that you saw in PowerPoint slides of evergreen students here, and it was an alfalfa field. And then here we have a great place to go really. Wow, sorry. Sorry, Zach, we didn't know you were there. Here's a brand new field. This was alfalfa field 2 years ago, and then now it's been converted. And so now this will grow up into forest. So, in fact, a good number of the forests that we saw as we came in have been recently converted. Interestingly, though, I think the growth of these trees hits kind of a plateau. So in their growth early on, they were some of the most productive forests we've ever seen. But I think they hit a plateau. This stand that you see out here, that large one, we did field research in that in 2006, 2007. It looked almost identical. It really hasn't changed.
Because of the nitrogen from the alfalfa field?
That helps with the immediate growth. I think the growth is most helped by the fact that they have, for some of them, a 330-day growing season. So even with a moderate productivity rate.
I just kept hearing using converted alfalfa fields, and that's all I could think about.
There's a lot of nitrogen in there. That's right. That's right. Yeah, and that's certainly. It's going to play into them really not being nitrogen limited. Yeah, and they were not only are they alfalfa fields, they were laser leveled alfalfa fields.
Yeah.
And so they cleared these things. They, set up their tripods, make sure the ground is perfectly even. There's no topographical variation, so they can flood it and get the same depth all the way across. And then these guys, so it's not just alfalfa. It was as uniform as you can make 40 acres. Yeah.
So most of these trees were planted by people, right?
Absolutely.
So how able are they to reestablish themselves and
there's no flooding here that's going to help them reestablish, and so not very.
Okay.
Yeah.
So if we just leave these, then eventually they'll probably die out again.
Unless we have regular flooding that comes out and is timed with the release of seeds. And you saw some cottonwood fluff already flying. So some of these guys will already be in seed mode. Some of them haven't leafed out yet. You have a tremendous diversity of cottonwoods around you right now.
The river's so channelized, it'll never get a chance to do any
so
natural.
It has to be an organic machine kind of thing, where we're like, well, just the same way we're going to release water from the dams to simulate floods, we're going to flood irrigate these to simulate floods once a year around the time the seeds drop in.
And it can't just be one large flood. It has to be a flood, and then it has to taper off, like you showed us on the paper, so that they can travel down. That's right. As the first period. Shoot, that's.
Oh, hawk just flew out of the stand. Clarissa's down there. Right out. It's a plane.
Are those kind of simulated floods? Are those things that we're able to do? Are we doing those things?
Yes, we are. Yeah, or we as in the culture is. Yes, they're happening, pretty regularly. Yeah, so despite what you hear in the news media, that stuff just kind of trucks along.
Is it difficult to do though? Like
Very, very, because they have to regulate. Farmers want this for they want this for fields. They want this for, and they don't just want this for like massive, chemically supported agriculture. This is going to like earthbound organic farms. There are organic, baby lettuce, baby spinach, farms downstream here that are using this water in canals like this to keep their fields going and to keep you supplied with organic greens all through the winter. So it's, again, this complexity, and you have to be able to work it out with them. They need enough water for their fields, and then there's the agriculture demand, then there's California's demand, and California gets priority choice. They're the first big straw. It's the history. It's just political history. Yeah, that's right.
So vegetarians are destroying the area.
No, I would say most of it's alfalfa. I chose greens because it hits us in Olympia, but I guarantee the beef and actually dairy. Dairy's the big one. California dairy is taking a lot of alfalfa.
Alfalfa stays here. It's all shipped overseas.
Yeah, cows still take up a lot of water.
A good amount of this is going to feed California dairy.
Hey Dylan.
Yeah.
Is there any concern about any of the non-native genotypes escaping from the experimental forest?
Yeah, it would be a concern, except that the forests here were so ravaged and eliminated. If you were here 20 years ago, you would not look around and see any of these trees, save this one. It would just be nothing but flat agricultural fields like we saw. So, this is completely knocked flat. And so the restoration began with the closest trees people could find, but it's guaranteed that the best adapted stock was wiped out. Right, and so we don't, just because this one survived doesn't make it best adapted. It's just one of the ones that's still here. So you could plant with those, but what our genetic trial really allows us to do is really determine who's best adapted, and then based on the wind pollination, there'll be some other selection events. This is a windy site. You're in the western Sonoran Desert now. It's a little bit different. A lot of open space. You'll see some of the same characters like saguaro and ocotillo. And down in the washes, you can even see some mistletoe from here. You'll see mistletoe on mesquite, and you'll find acacia. You'll find creosote bush, that sort of thing. It's going to be a windy day today, so be prepared for that.
Man, just a low point.
Yeah, I think we kind of got out of the wash over there, and now we're onto the sand.
One reminder, the snakes are out. Hey, okay, it's big numbers. So be aware of that. Watch out for each other. Watch out for anything that moves. Please don't try to grab it. Don't mess with it. Sit steady, roll, and stay in teams, please. Don't let anybody wander off alone. Sometimes people think I don't have a team, so I'm just going to wander off. When you you see that person wandering off by themselves, go check in with them. Make sure that they know. One of the first things that happens when you get really dehydrated is you tend to get angry and grumpy. One of the first signs of dehydration. So sometimes when that happens, people will have a tendency to want to be more alone. Bring them in. You're in a beautiful place, in a neat part of the world. Try water first, then continue your anger. But just, just try it.